This is Module 1, Lesson 4. Here we are looking at evaluating square roots, and then later we'll move into order of operations. So first, by definition, the square root of a number is one of two identical factors of that number. So for example, since 5 times 5 gives us 25, 5 is an identical factor of 25. Therefore, the square root of 25 is 5, and we write this as square root of 25 equals 5. Well, let's look at several examples. So first, let's find the square root of 36. So we're trying to think of what number times itself gives us 36. Well, I know that 6 times 6 is equal to 36. That tells me that 6 is an identical factor of 36. Therefore, the square root of 36 is 6. For 1, well, I know that 1 times 1 is equal to 1. Therefore, 1 is an identical factor of 1. So the square root of 1 is simply 1. For 121, once again, we're thinking of what number times itself gives us 121. I know that 11 times 11 is 121. Therefore, the square root of 121 must be 11. Lastly, for the square root of 0, well, I know that 0 times 0 equals 0. Therefore, 0 is an identical factor of 0. So the square root of 0 is 0. Now let's look at order of operations. Whenever we're simplifying a numerical expression, it's important to do so following the standard order of operations. This means first we do any operation involving parentheses or brackets or other grouping symbols such as fraction bars or square roots, making sure to start with the innermost set. Then we move on to evaluating expressions involving exponents, followed by multiplication or division in order from left to right, and lastly addition or subtraction, again from left to right. Many students will often remember this order of operation using the mnemonic device PEMDAS. This stands for parentheses, exponents, multiplication, division, addition, subtraction. Now I like to add a little grouping to my PEMDAS around the multiplication division with an arrow from left to right, reminding me that it must go from left to right, and then addition and subtraction again with that left to right arrow. So let's look at an example. For example 5, I have 5 squared times 4 divided by 2. So here, I don't have any parentheses or other grouping symbols, so I'm going to move on to exponents. I'll do that 5 squared. Well, 5 squared is 25. Now I'm simply going to copy the rest of the problem. So I still have times 4 and divided by 2. Now I move on to multiplication and division, remembering to go from left to right. So even though that 4 divided by 2 looks tempting, because then I would just have 25 times 2, I need to make sure I go left to right, meaning I need to make sure I first do 25 times 4 to get 100. Now I'm just going to copy down that 2. Now I can do 100 divided by 2 to get 50 as my answer. Alright, let's look at another example. So now I have 7 minus 3 quantities squared divided by 2 plus 6. So I start with the parentheses where I have that 7 minus 3 to get a 4. Again, I'm just going to copy what's left, the square divided by 2 plus 6. Now I move on to exponents. So 4 squared is my next step, that's 16, and I'm just copying down the remainder of the problem. I move on to multiplication and division, so I have to do 16 divided by 2, which is 8, plus the 6. So my last step is 8 plus 6, which is 14. I just want to reiterate how important it is that at every step we notice I simply copied down all parts of this problem until I was done using that part. This is useful to help us keep track of all of our symbols and operations so we don't lose anything. Alright, example 7. So now I have square root of 36 minus 1 divided by 7 minus 2. Now here, this is an example where we have other grouping symbols beyond the parentheses that we need to make sure we do first. This fraction bar here that's dividing the square root of 36 minus 1 by that 7 minus 2 is acting as a set of parentheses. It's telling me to do that numerator stuff first, then do the denominator stuff, and lastly I can move to that division. So I want to start by doing the square root of 36 minus 1. Well, the square root of 36 is 6. I'm just going to copy the minus 1, divide by, well, the 7 minus 2 is a 5. So now I can continue to simplify in that numerator. I still have 6 minus 1 is 5, divided by the 5. So finally I can do 5 divided by 5, which comes out to 1.
Now in question number 8, I see I have the absolute value of 5 minus 2 within my problem. These absolute value symbols act as another form of grouping or parentheses that I need to start with. So the first thing I'm doing is 5 minus 2, which is 3, and the absolute value of 3 is also 3. Now notice that minus sign is in front of the absolute values, so that's something I need to copy down, as well as the 3 squared in the beginning. Now that my parentheses or grouping symbols are all gone, I move on to exponents. So 3 squared is 9 minus the 3, and lastly 9 minus 3 is 6 for my final answer. On question number 9 now, we actually have two sets of grouping symbols. We have the absolute value of negative 75 that I need to start with, but I also have this fraction bar that acts as grouping the numerator and grouping the denominator. So I'll start off with the absolute value of negative 75, which is positive 75. I still have that plus 5 and divided by 5. Now I need to deal with the grouping caused by that division bar, so I have the 75 plus 5, which is 80. Now that divided by 5. Well, I don't know 80 divided by 5 in my head, so I'm going to pull it off to the side as long division. 80 divided by 5. 5 goes into 8 one time. 1 times 5 is 5. Subtract, I see I have 3. Pull down the 0. 5 goes into 30 6 times. 6 times 5 is 30, so I have 0 remainder. So 80 divided by 5 is 16 as my final answer. Okay, on to number 10. So first we start with parentheses, and I see I have 4 1/10 plus 4/10 within my parentheses. Well, it might be useful to pull that off to the side that I have the 4 1/10, which I'm adding to the 4/10. Remember, when adding decimals, we line up those decimal places and then add normally. So 1 plus 4 is 5. Bring down that decimal point right underneath it. 4 plus 0 is 4. Okay, so inside those parentheses, I have that 4 1/10 plus 4/10 is 4 5/10. Copying everything else down, I still have divided by 5 times 2.2. Now I move on from parentheses to multiplication and division, working left to right. So first I see this division that I need to start with. That is the leftmost operation between that and the multiplication. So I need to do 4 5/10 divided by 5. Again, I'm going to pull this off to the side. So over here I have the 4 5/10 divided by 5. Now remember, when dividing decimals, all we're concerned about is that the divisor, the number on the outside, is a whole number. In this case it is, so I don't need to move my decimal place. I'm just going to simply bring it right up into my answer. So 5 goes into 4 0 times. So I'm asking myself instead, 5 goes into 45. Well, that's 9 times. And 9 times 5 I know is 45. When I subtract, I see 0 remainder. So 4.5 divided by 5 is 9/10, which I now need to multiply by 2.2. So once again, I'll pull this off to the side. I have that I'm going to choose to put the 2.2 as the first number and the 9/10 as the second number, simply because that gives me fewer numbers that I need to run through as far as that multiplication from that bottom row. So I have 9 times 2 is 18, carry the 1. 9 times 2 is 18 plus the 1 is 19. And now I see that in my original problem, I had 2 decimal places. So from the end, I move my answer in 2 decimal places, and I see that my final answer is 1 and 98 hundredths.